Hello, my name is Trisman Loomis, and I'm an engineer at Preferred Networks. Today I'll be presenting on hyperparameter importance. So a little bit more about myself. I live in Japan, and as mentioned, have been working for a company called Preferred Networks in Japan, which is one of the premier industrial deep learning companies in Japan. Previously, I worked on the chainer team within Preferred Networks, which is one of the precursors of PyTorch, and helped define the define by run algorithm. Although now I'm on the auto machine learning team, specifically working on the Optuna team. So to give you an overview of what we'll be talking about tonight, the first thing we're going to talk about is what are hyperparameters. And then from there, we'll talk more about what the impact is on your performance of your algorithms. And then talk about current usage, how people currently usually tune hyperparameters. After that, we'll go into some of the criteria of how you could choose which hyperparameters you should tune. And then talk more about Optuna, which is a particular example of a hyperparameter optimization framework, which goes very well with Python programs and in specific with PyTorch. And we'll look and see how it could look inside of PyTorch itself. Then we'll talk about how many hyperparameters you should tune at a time and how you can go about choosing them. So starting ahead with what are hyperparameters. Typically in the deep learning world, you might think of hyperparameters as the number of layers or the number of units within each layer, or perhaps the learning rate of your optimizer. Generally, they are controlling the behavior of the algorithms, and they're determining the performance of those algorithms, how well they actually do, and they're typically set manually. And we'll say more about that in a minute. But they also determine the success or failure of your overall algorithms. So object detection with a bad threshold parameter you can see on the left can produce too many bounding boxes in this particular case of the threshold hyperparameter. And with a good threshold hyperparameter, it can provide a much more clean resolution where you have one bounding box basically per object. But these are not the only hyperparameters. There might be more than you thought of before. If you just take a look at the image itself, there's the encoding that's used for the image, also what the order, the image size is that's used, or the JPEG decoder. Then within the neural network trainer, there's the batch size, what optimizer is chosen, stochastic gradient descent, atom, momentum, or others, and then the learning rate that's used by that optimizer itself. In this particular case, since we're looking at a detector model, there's all of the visual information for the CNN, the backbone architecture, whether VGG or ResNet, the kernel size that's used to go over the image, batch normalization, order, and other things. And then down at the hardware layer, you might be looking at whether you want to use floating point 16 or FP32 or mixed precision. Or on a NVIDIA GPU, you might be looking at what CUDA kernel parameters you want to use. But generally, swimming in too many of these can then cause you to have a different issue. But let's take a look at the impact of how this works. So we looked at a hyperparameter optimization paper that looked at the review of the algorithms and applications, and found that if you compared doing a random search with Bayesian optimization compared to hyperband and Bayesian optimization with hyperband, it could provide almost a 20 times speed up. And this advantage persisted at the long time frames as well, and could increase actually to up to a 50+ times speed up. So the hyperparameters make a great difference to what the overall performance is. But if you look at the current practice in them, there was a survey that was done of machine learning experimental methods at NeurIPS 2019 and ICLR 2020, and it found that of all the people who were working with programs that have hyperparameters, the majority of them were doing either not tuning them, manual tuning, or random search, and that only about 6% of the people were using a hyperparameter optimization framework. So given the huge benefits that can be available by tuning the hyperparameters, we think this is a real opportunity for improving the general performance of PyTorch and deep learning. But the problem is that if you try to optimize all of those hyperparameters simultaneously, you're going to run into the curse of dimensionality. With all of those hyperparameters tuning at the same time, the search space becomes too highly dimensional, and it will take a long time for any hyperparameter optimization framework to find the best hyperparameters. So in order to combat this, we took a look at it in a paper for the efficient approach for assessing hyperparameter importance. And hyperparameter importance is basically a way that you can take a look and find out which of the hyperparameters it is that makes the most difference to the overall performance of your algorithms. And taking a look at this, we then implemented this hyperparameter importance into the Optuna framework, which we believe is the next generation hyperparameter optimization framework, because it allows you to then not only optimize your hyperparameters, but using hyperparameters can help you to select the most important ones to work with. So let's take a look at how this could look in PyTorch. So in the model definition, basically then we have to define a trial. This is doing a simple mnist. And around on the 5th line, you see the out features uses the input trial object that was put into the function and gives a trial suggest integer for the number of units in the layer between 4 and 128. And then also uses a categorical list of either ReLU or TAN for the activation for each layer. And then the next line provides a float for the dropout value, which ranges from 0.2 to 0.5. And notice that all of these hyperparameters are actually defined within the actual code itself in a define by run kind of way, where it's very intuitive to see what the range is, and it's defined using Pythonic syntax for easy troubleshooting and definition. Then as we go on to the objective function, you can see that within the objective function as well, we need to have a trial object which is passed. And this objective function is then used by Optuna to review and evaluate how well the trial performed. And in this one, we have an optimizer name, which is also given by the trial object in suggest categorical, which then picks the optimizer from a list of atom, RMS prompt, and stochastic gradient descent. And then the next line gives us a log uniform, which is a float which varies logarithmically to give us the full range of possible learning rates between 10 to the -5th and 10 to the -1. So then looking at the results of this simple mnist example, we find some things that maybe confirm what you might have guessed, which is that learning rate is the most important hyperparameter. But then the next most important hyperparameter at half the importance of the learning rate is actually the number of units in the very first layer. The number of units in the second layer is much less important, less than 1/5 as important. And then the third most important hyperparameter is which optimizer was used, which you might have guessed was an important factor. But again, this is not as important as the number of units in the first layer. And then beyond that, we see the dropout layer in the first layer is also one of the important hyperparameters, and other hyperparameters are less so. So how many hyperparameters do we recommend that you should pick? From our experience, for reasonable time versus performance, about the top 3 to 5 hyperparameters are the best hyperparameters to focus on. So the steps then for tuning and using hyperparameter importance is to start with basically tuning all the hyperparameters you think might matter for the first 100 or so trials to give yourself a solid baseline and to give Optuna some time to search the hyperparameter space. Then pick about the 3 to 5 hyperparameters using hyperparameter importance to see which ones have the most impact on the performance of your algorithm. And then run the rest of the trials with the time or compute that you have available to you and hopefully win. So as you can see, there's kind of a hyperparameter evolution. So I think the first step is just using sort of the default or not tuning the hyperparameters. And the next step is manually fidgeting with those hyperparameters to see which is the most important. Then after that, maybe using a grid search, and then hopefully using a hyperparameter optimizer like Optuna to systematically, using Bayesian optimization, look for the best hyperparameters. And then finally, hopefully using Optuna leverage with hyperparameter importance so that you limit it down to the hyperparameters which have the most impact on your overall performance. These are some of the resources that you can look at for more information. There's optuna.org, which is the homepage for Optuna, our GitHub at Optuna. Also, there is an ecosystem presentation on using Optuna with PyTorch, which you can find by Googling. And then also we have the papers which I've referred to in this discussion. So thank you for your attention, and I hope that you found Optuna interesting and have a good rest of your PyTorch Dev Day. Thank you.